welcome back everybody for the second half of our hypothesis snapshot. I hope you looked at this particular problem. If not, stop the video, work the problem. Here we go. So you've read over the problem, right? Our hypothesis here, or the null hypothesis, is that, again, the status quo. Right now, let me get my black marker working here. H naught is that the mean cost in 2016 is still $30,000, right? The status quo. The claim being made here is that the mean cost has changed. It's changed. We didn't say it was larger. We didn't say it was smaller. It's different than 30,000, right? Okay? So again, the null hypothesis is always the status quo. The alternative is the claim that's being made in terms of things being different. Here, we don't care about being larger or smaller. Either one is different, right? So our region of rejection, okay, so again, we have $30,000 right here. But again, we don't care if we're too large or too small in terms of the sample, correct? So we're going to have two regions of rejections here. That is, our alpha value, which is 0.01, is going to be split into half. So this is going to be 0.005 in this region and 0.005 in this region. So be careful when you look up your scores, right? Now, I took a sample. I have the sample standard deviation. Since I have the sample standard deviation, I will be working with a t-score, okay? So my degrees of freedom in this particular problem is going to be 14 minus 1, which is 13. I'm going to be looking up an alpha divided by 2 value of 0.005. You go find that in the table and then come right back. All right, so you've looked that number up, correct? You found that number in the t-table to be 3.012, correct? But again, on the left-hand side, this is going to be a negative value, right? Now, test value, once again, is how do we get to the table? We have to subtract the mean divided by the standard deviation. We don't have the population standard deviation. We have the sample. But again, basically the formula is the same. Divide the sample standard deviation by the square root of the sample size, right? We get a value of 1,202.68. Oh, what happened here? Okay, all right, let's fix that. Again, I don't edit any of this stuff, right? Okay, 68, right? So my t value, that is the test value, is the sample mean. Got to find my sample mean now. I think I'll move up here. 34,000 minus the null hypothesis mean divided by the standard deviation. Do your math, and you get a t-score of 3.3259. Okay? That value does fall in the region of rejection. So again, we reject. I'm going to just write it out quickly here. We reject with the probability of committing a type 1 error, right? That is, we rejected, but we might not have, or might not should have whatever, right? I mean, maybe we shouldn't have rejected. All right, it's kind of early in the morning here, but anyway, keep it. We're just going to keep moving here, right? Okay, understood. Once again, we'll move on to the. Oh no, we got a part B here. Again, this is only a change in the level of significance, okay? I think this is supposed to be different. I'm wondering about this here. I got a change in my lecture notes here. Okay, let me see. Let me hold up here for a second. I hope I caught this. Okay, we do have a mistake here, but you shouldn't see it in your printout, okay? Because I should have it fixed, okay? That level of significance was supposed to be 0.002. Okay, that's what you should see in your notes if you printed them out. All right, so here, once again, we're rejecting if we are too large or too small. Once again, we are working with a t-score because we do not know what the population standard deviation is. Again, our degrees of freedom is 14 minus 1, right? Which is 13. When you look up your t-score, remember that the 0.02 is being split up into two particular regions, so we're really looking up the value 0.001, correct? The t-value associated with 0.001 and degrees of freedom 13, I came up with 3.852. So over here, it's negative 3.852 because again, I'm below the sample mean, the assumed population mean here, right? So there's my t-score. I still work with the same value I got up here. I got 3.32. That particular value does not fall in the region of rejection. So at this particular level, I do not reject, okay? Do not reject with the possibility of a type 2 error. All right, I'm going to move on. Moving on. This last problem, again, read it over, work it out. I got a lot of corrections here, so hopefully I'll fix these problems here. But anyway, we'll find out. Anyway, look at the problem, work it out, stop the video, replay the video. I'll assume you're going now, but I am looking for a hypothesis test for a proportion, right? So we're going to have slightly different formulas here. But once again, the null hypothesis is always the status quo. For our problem here, the proportion of defects is still at 0.0525. The alternative, somebody is claiming that the new process actually increases the proportion of defective light bulbs, right? So maybe we got better mean life, but on the other hand, maybe the number of defects is actually increasing. So you never know here, right? So hopefully you're getting something out of all this statistical stuff and getting a feel for the importance of statistics here, right? And things you have to take in consideration. All right, so there's my null hypothesis, the status quo. The claim that it's actually going to increase the percentage of defective light bulbs. I am working with a proportion, so I'm working with a z-score. I am looking to see or claiming that there's been an increase, and if I'm claiming there's going to be increase, then I'm going to reject if I am significantly higher than what the assumed null hypothesis claim is, right? Which is 0.0525, right? Now, I'm working with a z-score. The level of significance is 0.10. If you look up this z-score, you should find a value of 1.282. My test value, again, is how do I get to the table? Well, once again, I am working with a proportion. I do know what the sample proportion standard deviation is because, again, I have a formula. That formula is p hat times 1 minus p hat divided by n, correct? P hat in the problem, the sample proportion, p hat, is, well, how many defects did I have? I'm trying to find 40 out of 600, correct? And so 40 divided by 600, let me check this, make sure. I got a lot of corrections on my paper here. Okay, continue on. Yes, it's correct. I like to change my numbers sometimes, and my paper looks like a mess when I do that. So anyway, we have confirmed that p hat is this number here. So the opposite of p hat is going to be 0.9333. If you plug these numbers into the formula, and you divide by n, which is equal to 600, do your math, you're going to come out with sigma equal to 0.0456. Okay? Wait, no, hold on. Let me hold on here. I got to erase that. Grabbed the wrong number, I believe. Okay, yeah, that correct number is 0.1018. All right, that's what sigma is. You do your math. So then my test value, again, is z equal to the sample mean minus the assumed mean divided by the standard deviation. You get your calculation, and it comes out to be 1.3949. That is in the region of rejection. So we reject with the possibility of committing a type 1 error. And the probability that we committed a type 1 error is our level of significance, which is 10%. Okay? So I hope this little short video helps a bit. That is it. See you in the next one, right?